Hello, everyone who's online. Welcome. Today we're going to have a wonderful fireside chat with Paul and Brad, Paul Dix and Brad Bebee of AWS. We're going to be talking about the new Influx and AWS offerings. I'm your host today, Andrew Lamb. I'm a staff engineer at InfluxData, and I'm mostly going to just introduce the speakers and get myself out of the way. So first, let me introduce Paul, who's the co-founder and CTO of InfluxData. And a friend of mine. He created InfluxDB, which is, as you hopefully know, a purpose-built time series database that you collect, store, analyze all sorts of time series data. And prior to that, he worked at other companies such as Microsoft, Google, McAfee. Well, no, I guess he helped people build software for those people. Brad is a director at AWS and a general manager at Amazon. He believes that graphs and time series are awesome, as do most of us database engineers, I might point out. And I think helping customers use the relationships in their data to gain insights. Prior to AWS, he was the CEO of BlazeGraph and an open source contributor to the BlazeGraph platform based in Washington, D.C. So basically today what we're going to do is it's going to try to just basically have a good chat format, not too formal. I'm going to have a couple of prompts. We'll start, and I expect we'll just cover some very interesting things. So to get us started, maybe I think anytime time series people get together, we just assume everyone else talks about, like, knows what time series are. But maybe we should start with like a quickly high level discussion of what time series is and what makes it unique. What are some of the interesting challenges?
So thanks, Andrew. It's super cool to be with you guys today. Two of my favorite topics. The time series, in essence, is any time that you take sort of a sequence of measurements of data points over time. And what's super cool about it, the reason I think it's awesome, is that understanding time series and understanding how the measurements are changing over time is really fundamental to you getting an insight into what's going on in your systems. And what I see is that sometimes people think about time series and they have what I would consider a relatively narrow view of all the places that it shows up. But when you think about a problem, like if you're faced with trying to understand something that you don't know or that you can't always observe everything, the first thing you do is you start taking measurements, and you take measurements over and over again, and then you look at how those measurements are changing. Then you can start to build hypotheses and designs and understand what's going on. And so time series lets you do that. And what I see is that there's so many applications of time series that it's beyond where you kind of think of it normally. It's into low Earth orbit space satellites, it's into streaming video. And so the places where customers can benefit from time series is growing almost as fast as the amount of time series data itself. So I'd love to hear Paul's perspective.
Yeah, I mean, I think one of the things, like initially when I first thought about time series, like over a decade ago, like many people, I thought of essentially like measurements at fixed points in time, right? So basically like your CPU utilization sampled once every 10 seconds or the average response time to an API. And then as I've been working on this and seeing all sorts of ways people are using this data, my view on it is kind of like morphed into time series is actually just a way of doing analysis on observational data of any kind. Now, sometimes these observations look like metrics that are sampled at fixed intervals, but sometimes the observations are literally like, log lines or individual events on a machine and things like that. And you can essentially like induce time series on the fly from these things. So take something really simple like individual requests to an API, right? You have like the server, maybe the user who made the request, you have the actual response time, and there are just like a million different things you could measure there. That's basically just like an event stream. And then from that, you could induce all sorts of like time series, right? You could say like, what was my 95th percentile response time in 1 minute intervals for this 4-hour period of time, right? And all of that is basically just doing analysis so that, as you mentioned, Brad, you can, learn about what's going on, right? And what we see is two different things. One is basically like control of a system and basically monitoring that system to make sure it continues to operate well. And then the other side is basically optimization. And we see a lot of the optimization stuff, obviously in servers, because you always want to use less RAM, fewer CPUs to do the same amount of work, but also in machines, like in machines in factories and stuff like that, we see optimization being really important because people want to use, say, less electricity, or they want to use less power, and they want to like measure all of these things to find out how it changes over time. So it's kind of like, it's like this bimodal workload where one is very much like a control system workload that's like real time, and the other is this like improvement loop where you're doing analysis and iteration on whatever it is you happen to be measuring.
Maybe that's a good segue. We can talk. I came from a more classical sort of analytics OLAP background, and I think when I first encountered time series, it wasn't clear to me why we needed specialized time series databases. I have a much different perspective on that now, 4 years later. But I was wondering if you two might want to try to highlight some of the sort of technical differences or challenges with time series data over others.
Yeah, I mean, like the first time I ever gave a talk about InfluxDB that we were like doing this thing, this is in like the fall of 2013. And that was one of my early slides, which is basically like time series database. What? Like use a regular database, slap a time column on it, and order by that. There you go, dummy. No need to create a new database. But I think even 11 years ago, the challenges that I listed are still, I think, very much relevant today, which is like, one, the scale of time series data is just way, way bigger than what you see in traditional, like what's called OLTP workloads, right? Workloads where it's like, you have your customer database or your bank transactions or whatever. In time series data, you have thousands, tens of thousands, hundreds of thousands, millions of individual things that you're measuring at frequencies that range from, once an hour, once a day, to once a minute, once every 10 seconds, sometimes thousands of times a second. And basically what we see is even in modest workloads, you're talking about, into a normal database, what would be like, how many rows are you writing? You'd be writing like 10 billion rows per day, right? And that's like a modest, not crazy workload. So basically just the scale of the amount of data that you're ingesting is a big problem to deal with. Some of the other properties of it that make it so that you can like build optimizations is you're really not updating data, right? If you think about what you're doing, you're collecting a historical log of things that happened. So it's basically like this append-only workload where you're always just writing in new data. And if you're doing that, you can build optimizations around that. But some other common things are, one, you want to like downsample that data so you can summarize it so that it's more efficient to get larger and larger views, right? If you want to say like, oh, how did this thing trend over the last 6 months? Well, to do that on all the raw data might take more time than you want to wait. So you have the system essentially like downsample this data as you go so that when you look at a 6-month view, it'll return really quickly. Now, paired with that is this idea of like data lifecycle management, right? It's very common, I think, in these time series use cases where the data has a ton of value, like right when you're first ingesting it, right in the first like couple hours or a few days that you've, collected the data and gathered it together. But then the value of the data quickly like drops off, right? So what you want is a system that will let you kind of manage this life cycle to do downsampling, but then also age out the old data and do this very, very efficiently, right? Evict it from the database and free up disk space and all this other stuff. And again, like if you think about a traditional OLTP database, like the dumb way to implement something like this would basically just like to, say you wanted a 7-day, retention period for your raw, high precision data. A dumb way to do this would essentially be to delete every record after it hits 7 days worth of age. But if you've worked in databases a while, you know that like inserting 10 billion records a day and deleting 10 billion records a day would be absolutely ruinous for, for operational stability and your performance. So these kinds of things become important with this time series use case. Brad, do you have more thoughts on it?
Well, I mean, from an AWS perspective, we fundamentally believe in purpose-built databases, and so that for these kinds of workloads, when you get to the scale or the performance that you need, you're typically going to be better off with something that's built for purpose, and I think that's absolutely true in time series. I agree with all of the points that you mentioned. I think some of the other unique aspects operationally are sometimes data can arrive at different times. And so often the things that you want to measure aren't necessarily online. So you have to, think about, you get series of time series that arrive potentially out of order. You need to, as a customer, you need to think about your ingestion rate, the latency that you want from ingestion to query, the way, whether you're thinking about alerting, monitoring, or optimizing kinds of pieces. And then, of course, many different time series workloads have different sets of cardinality associated with the measures on them. And that can be very challenging for, different sort of or non-purpose built time series systems to process.
So that's pretty good. I think we've had a good technical deep dive. Maybe I wonder if you guys could describe some of like the actual use cases of this, like for real, or maybe with real customers or something, to make it a little more specific.
Yeah, I mean, I really resonated with kind of the way Paul was thinking about the optimizing as one of the use cases for time series. One of the things that we see customers doing with it is not just optimizing for performance or cost, but optimizing for things like user experience, optimizing for security kinds of pieces. And so, if you've ever watched Amazon Prime NFL Thursday night video, that live stream of video uses a time series that's managed by TimeStream. And what they do is they look at that time series, and in real time they adjust based on the user's experience. And by doing that, they're able to achieve very large scale and a high quality broadcast. I see some similar kinds of things. VMware's Carbon Black, basically they provide endpoint security. And Paul was mentioning sequences of API calls, and what they do is they use those sequences of API calls, and they construct time series, and they use those time series to help understand if something's going on that should be or that shouldn't be. And so, those are a couple of examples off the top of my head, but I think that that sort of concept of optimization is, as a user or someone building systems with time series, I would encourage people to think really broadly, because there's lots of different things that you can do with that kind of time series understanding, to improve your customer experience, make it more secure, reduce your costs, in addition to some of the things that you might traditionally think about doing with time series.
Yeah, I think for software developers, like the most obvious points are going to be like, okay, monitoring what's going on in your servers, tracking your system level stats like CPU and memory and disk and network. Monitoring, custom application metrics within your own code where you create those, like all of that is like time series data when you think about it. But in specific industries, the way I like to think about it is like, if you have a machine that you're operating and you care about the efficiency of its use and its continued health, then you probably are going to be, creating, collecting, analyzing, and keeping track of a lot of time series data. So, machines could be rockets that you're launching, satellites, communication satellites. The communication satellites one is interesting. We have customers in that space who, again, are like, they're monitoring how the satellites are communicating back to the ground stations and like all this other stuff. There's wireless telecommunications, right? Different like point-to-point wireless systems. Then, in energy, there's, solar power generation, wind farms, actual regular like traditional power plants, like all of these things, like any like process where you have machines doing things and you have to continuously operate them. That's definitely like, those are all huge time series use cases. But I like the one that you mentioned, Brad, which is really like thinking about time series for optimizing user experiences, right? If you're creating web applications or mobile applications or anything where you have a user experience, you need to measure that thing and measure it over time. So you're into time series data right there.
Yeah, cool. I think one of the more exciting things I've heard about happening in the time series world is that there's this new offering between AWS and Influx, which I think are both. I think obviously that's why we're here. One of the major things we're here to talk about. So I wonder if one of you or both of you would like to tell us a little bit more about this offering.
Sure. So, I think there's the time stream for InfluxDB, which we launched in the middle of March. It's generally available. Is an AWS managed service for open source InfluxDB, and it really kind of combines a couple of things that I see as really important trends. And obviously we've talked a lot about time series and the broadening and growth of applications in time series. But also the thing that we see is that customers really love managed open source offerings and managed open source databases in particular. Open source databases give customers API choice. They give them the transparency into the engines and other aspects. But sometimes it can be challenging to manage and operate them at scale. And so with TimeStream for InfluxDB, we take the most popular open source or the most popular time series database, if you will, and we give customers, AWS customers, the option to have a fully managed version of that open source engine. And so that's something that we have many different managed open source database services and over 20 different managed open source AWS services. So it's something that we know customers really love, and it's super exciting that we're able to offer this in partnership with InfluxData.
Yeah, Paul, can you tell us a little bit about specifically which version of Influx is used and how?
So the AWS offering is based off of InfluxDB version 2, which I think we launched the alpha of that in early 2019, and then later the full release in November of 2020. Or maybe it was beginning of 2020 was the alpha, and then November was the GA release. So that is, our all-in-one database that contains not just the database, but also a user interface and a number of other things for basically processing data on the back end. A language we created called Flux and tasks, which makes it so that you can schedule the database to run, jobs on some regular basis, to do, downsampling analysis, interact with third-party systems like, send data out to other systems or send, monitoring alerts or things like that. We are also currently working on version 3 of the database. We launched our own versions of the distributed version 3 last year, and we'll be launching basically open source and partnering with Amazon to get version 3 available as soon as we can. That is an ongoing development effort.
Yeah, no, we're smirking because Paul and I are involved in that deeply. So one thing that might help clarify for people is so if I'm a happy open source user today of Influx DB2, right, the current open source one, what sort of benefits would I get, or when would I want to be thinking about AWS?
So, the benefit of a managed database service and the AWS managed InfluxDB service is that, you can free up the time that you're spending managing your servers, managing the database, patching, backups, maintenance windows, and you can spend more time building and using your time series data to get insights into your business. And so if you have a self-managed InfluxDB2, you might consider moving it to the AWS managed InfluxDB service for that reason. So you no longer have to do the management or the host patching. Those things all take time. It's very easy to migrate. So you can take. We have a couple of different options where you can take a snapshot of the data that you have on your existing one. You can run them in parallel. There's different choices depending on your application pieces. And since we launched just almost 2 months ago, exactly to the day today, we've had hundreds of customers start using the service, and it's been very popular. And I think it's really because of those trends that I talked about earlier, that customers love open source databases and they don't like having to manage them. And so we always work backwards from customers. And so if we're really interested in how it works for people who have self-managed Influx 2, if there's ways that we can improve it. And we're really interested, in continuing to work with InfluxData as they make Influx 3 versions available in open source, and other pieces. So I think that's really how I look at the benefits for customers.
Do you want to talk, Paul, about some of the transition from 2 to 3, or focus on the features maybe for 2 that are currently available, and then how you're seeing the future evolve?
Yeah, I mean, well, we can talk about 2 to 3, but there's a fairly large shift, and given that 3 isn't available yet in the Amazon offering, I think maybe keeping the focus on 2 is good. So the interesting thing is with version 2, we built new APIs and this new language and stuff like that. But version 2 of InfluxDB actually also supports the version 1 API if you enable it, like when you're in there. So you can interact with the version 2 database as though it were a version 1 database, and you could use it just with those features if you wanted to. And similarly, version 3 will be bringing forward the version 1 APIs and some of the version 2 APIs, and obviously also all new like version 3 functionality. I think one of the things we're currently working on that is interesting for people who are signing up for the AWS hosted InfluxDB service is essentially a highly available configuration. Right now, they currently have a high available configuration, but it's basically data durability in multiple AZs with a hot standby so that, if you have a failure, this other one comes back up. But what we're working on kind of together is a version where you can have other servers in other AZs that are actually hot for reads, and they are the failover to one of those as the primary is much faster. So we're active at work on that. We'll be having that come out soon, and I think that'll be a real differentiator in terms of people who are running open source just on their own, open source version 2 versus going with the Amazon service, because that capability is something that isn't available in the open source. And you'd get that essentially as an unlock in the Amazon hosted service, which I think is really powerful.
Yeah, in my past lives, I've gone through that transition of I ran open source, it was working great, and now it's like now I got to deal with managing it. I've done both, try to do it myself, and then also just we did hosted Mongo, and it was worlds like never looked back. That was absolutely the right choice. So it's great to hear some of these other features that are being added to make the experience when you're using the hosted version of Influx great. I mean, it's I'm sure at least I as my former user self would definitely appreciate it.
Yeah, I mean, I don't want to operate a database as a user. No.
No, I think
I like operating database services, but as a user, we want to make it easy for you guys to run your own database.
Yeah. You don't understand how much of a investment that is until you've had to do it for a while, right? Like, because it works great when you first get it up. Like, what's so hard about this, right? And then you have to patch it, or like it fails for some reason, or the hard drive, like.
Yeah, I mean, I think Paul mentioned the high availability aspect, and I think one of the things that customers have given us feedback on with the service to date is that the hot standby multi-AZ availability, that's something that customers have built a lot of different scripts and other kinds of techniques to kind of have that sort of availability of their data in another AZ in the case of a failover, and so they really appreciate that sort of aspect of it, because it just takes a lot of maintenance and management of it. And with what we're working on with InfluxData, I think that's going to be even more compelling, because it gives you the ability to scale your read throughput and do different kinds of have latency improvements based on co-location to your applications and different availability zones and pieces. So really excited about that aspect too. But I think that's something that we see from customers.
Yeah, 100%. Like when I was working at in these past lives, if you wanted those features, right, and you didn't have them yourself, you had to basically build the talent internally to build the scripts or whatever you talk about. And my strong suspicion is AWS and Influx have quite a bit more experience and understanding of how to build like scripts that are going to work correctly under load and fail over, and like know how to do all the testing and stuff. So my strong suspicion is the quality of the offering is much higher than you're able to generate. Most other customers could do themselves.
We do a lot of work internally. I mean, I think as we've all have experienced, we thought we built something that was robust, and then everything went away, and we found out maybe it wasn't as robust as we thought. And I think that's something that we really do well at AWS. It's one of our kind of core strengths, and I think that it's something that we're really excited to offer to customers.
Yeah, huge value add. So I guess, Paul, did you have something else you want to say?
Nope.
No, so let's
keep going.
We'll bring it back to like like, so how do I get started, right? Like when should I use TimeStream versus InfluxDB for TimeStream, if I get the right words, versus like just open source or vice versa? What would you guys recommend, or something else?
I mean, from my perspective, if you're running InfluxDB2X, the open source version, and you're managing it yourself, our goal is for it to be a better experience and more cost effective for you to use the managed service. And so, if you're in that category of kind of InfluxDB2X self-managed customer, I think that TimeStream for InfluxDB should be a big win. In terms of freeing up your time. I think, the breadth of time series use cases that we talked about earlier, really kind of, encourages you to look at different architectures in different ways, different performance characteristics in other pieces. And, as you look at that, you can look at the different characteristics. But, what we see as customers really like about is keeping on the open source APIs and then having that managed aspect.
Yeah, I mean, I think if you're in AWS and you want InfluxDB2, like it doesn't make sense to run it yourself. Like it just makes more sense to run the AWS service, right? It's like if I'm going to run Postgres inside of AWS, I'm not going to like run my own Postgres server. I'm going to use RDS or Aurora. So, I think the interesting question is, when would you use TimeStream for InfluxDB versus TimeStream for live analytics? I don't know if I have those reversed or in the correct.
That's right.
Okay, yeah. It's because those are two different products. They're both in the TimeStream family, and they're both time series databases. But yeah, Brad, what would you say to that?
Yeah, so TimeStream for live analytics is a fully serverless service, and so it's kind of for the AWS users, it's serverless like Dynamo, if you will. So you have an endpoint per region, and you can write data to it. And the things that it does really well are workloads where you're writing a very little bit of data, rarely. So small reporting, you benefit from the serverless aspect. Or where you have really periods of high ingestion. And so being a serverless service, we can aggregate lots of different resources behind the scene. And so we have some very large customers that are using TimeStream for live analytics to support some of their big burstable type of cases. On the other hand, TimeStream for live analytics doesn't have an open source API. It does offer a SQL interface and has APIs for adding data and and managing the different time series that you have. But if you really, if you want strongly to have open APIs, and also if you want to have very low latencies, and so if you're looking at kind of alerting applications where you need to have single-digit millisecond types of latencies for dashboarding or reporting, TimeStream for InfluxDB can be a really great fit.
You want to talk about other like offerings or like workload sizes where different offerings make, like the burstable makes a huge amount of sense, right? Where you all of a sudden have everywhere.
Yeah, I mean, I guess I can talk a little bit about what we've done in version 3 versus version 2. So versions 1 and 2 of InfluxDB at their core use a storage engine that we basically built from scratch. And we built this for the time series use case. And honestly, at that time, it's like a storage engine that's optimized for kind of the metrics side of time series, which means it's really, really fast and good if you have, somewhere on the order of like millions or tens of millions of individual time series that you're tracking and you're ingesting data. And your queries query, one or a few dozen or maybe a few hundred of those individual time series at a time, right? So your query essentially, like if you have 10 million time series that you're tracking once every minute, that's a lot of data if your queries are basically only hitting, are only going to return, a few thousand rows of all that data. But the version 1 and 2 storage engine were essentially like two storage engines in one. There was an inverted index that made it very, very fast to map metadata about time series to then the time series data store, which made it very fast to say, for this time series, give me this data for this range of time. right? So those things were very fast. But the trade-off there was that we do a lot of indexing as data is ingested, and it takes a lot more storage, right? Because you have to store the index and you have to store the actual raw data. And all of this it's all built around the idea that you have a locally attached SSD or like EBS with provisioned IOPS, right? You have a high performance disk where you can do a bunch of IO on it. Now, what we've heard over a number of years is people wanted, one, a little bit more flexibility so they don't do all this crazy indexing like up front. They like the ability to kind of like tune what gets indexed and what doesn't. They definitely want to use object storage as the backing store, right? Particularly for historical data, right? I mentioned earlier, like the value of the data has this like really big drop off in terms of its age. So people want the historical data available, but they don't want to pay, SSD prices for all data for all time. So object storage, cheaper ingest, use fewer CPUs and less RAM. And then more broadly, we heard people ask for greater like ecosystem compatibility, right? They wanted to be able to query using SQL, not just, R2 languages, InfluxQL and Flux. They wanted to be able to get at the data in bulk in a format that they could use out in other tools, right? In version 3, this is Apache Parquet, which is the file format of the data. So when we went about building version 3, we're like, okay, we need to support object storage. We need to support infinite cardinality in terms of the dimensionality of the data that you're pulling in. And we need to support SQL and a data format that people can use in other third-party systems, right? And other data warehouses and all this other stuff. So coming over to version 3, we built, the thing we launched into market last year, which we have a hosted offering on AWS, which is essentially we pulled the database apart into multiple services so that it's scalable on these different levels. Ingest is scalable separately from queries, which is scalable separately from the compaction and indexing work that happens outside of those other two. So version 3 of the database is much more interesting in terms of how dynamically it can scale, because it's all designed to run inside of Kubernetes and all this other kind of stuff. And also that can use those other external services, right? S3 is the backing store for durability. Now, version 2, open source, is essentially it's a monolithic piece of software, right? It runs on one server. It has a locally attached disk or an EBS volume, and even when we have the high availability replicas and other AZs, those are basically complete copies of the other ones. So, as Brad mentioned, that lets you scale your query throughput, the number of queries you can execute, but doesn't help you scale ingest. You're still kind of capped at what a single server can do. And as I mentioned in version 2, there's all this indexing that you're doing on the front end when you're writing the data in. And shockingly, like in these time series use cases, there's a lot of data that actually never gets queried, right? It gets written in, and we're doing all this work to index it up front just to have it never get queried. So with version 3, we made the trade-off where we're just going to organize the data into big chunks and have a query engine that's super, super fast. It's a columnar query engine called Data Fusion. That's an open source Apache project. And basically when queries come in, we'll just like brute force it and return the result. So I think version 3 will be interesting for all those reasons of, scalability, where you have different pieces that can be scaled independently of each other. You have an object store that is basically infinitely scalable for your data. So, yeah.
I think we just got an interesting question from the audience, which maybe I can read. And I think it's kind of related to what we were just talking about. And it'd be cool if we talk about this both in terms of the current offerings and where we see things headed. So here's the quote. It's, I understand time series database is a scalable, suitable for huge volumes of intake. In other words, it's optimized for writes, right? But is it also suitable for running analytics? In other words, reads, or is it recommended to offload the data, right, to some other database that's suitable for running analytics? Yeah. I don't know. I'm sure Paul has some thoughts on that. I don't know if Brad.
I definitely do, but Brad, you can say something first if you prefer.
Yeah, I mean, I think so. So the short answer is yes, but you have to think about the different architectures and the service pieces, and also what kinds of analytics are you running? Like if you're running, time, if the analytics you're running fundamentally are time series analytics, then you absolutely can use these services in the different flavors and offerings of them to do those kind of analytic pieces. As Paul mentioned, I think one of the neat things about the sort of the Influx 3.0 architecture is that you can actually get at that time series data in the Parquet format and use it easily with other kinds of analytic processing. And so you can do your purpose-built time series analytics on in the time series database itself. But if you also want to put it in your data warehouse, or if you also have something else, you can use that data, and you don't need to do the data movement to get to that. So I think it's a good insight that you need to think about the characteristics of your workloads in terms of writes, reads, analytic types of processing. But you absolutely can use the different options for these time series databases to do all parts of that processing.
Yeah. I'll say for version 2, the Flux language that we have in it lets you express like very, very complicated like analytic things. Like there are a bunch of analytic functions built in and all this other stuff. But I will say that it's not because of the storage engine and the way the data is organized on disk, and because of the way the query engine works, it's not optimized to do large scale analytics, right? So if you want to do like if you tracking a fleet of machines or a fleet of servers, and you want to do like fleet-wide analytics, that unfortunately is something that is not going to be very fast in version 2. And again, like this is a request that we got again and again and again from version 1 users and version 2 users. So when we built version 3, we're like, okay, how can we build a system where you would be able to do fleet-wide analytics and have it actually return in a reasonable amount of time and be pretty fast, right? And the bet that we made was essentially that an in-memory columnar database would be the thing that would like let you do that, right? So version 3 is a columnar database at its core, which means it's really heavily optimized for those kinds of analytic queries. So you could do fleet-wide analytics on it. At the same time, we also, as I mentioned, we have this like goal of broader ecosystem compatibility. So we support Parquet. One of the other things we're excited about that we're going to be supporting later this year is Apache Iceberg, right? And my understanding is AWS is doing a bunch of work around Apache Iceberg, right? So Iceberg is an open source project under the Apache Foundation. It was originally built at Netflix and is a standard for what's called creating a catalog of data, right? Which is just tables of data that are Parquet files and object storage. It also supports Abro and Orc, but really everybody's just using it for Parquet. And a bunch of the different data warehouse vendors are starting to build in support for this. So Athena in AWS already supports this. I believe Redshift also supports it. So essentially, like once you have your data registered, like the Parquet files registered in an Iceberg catalog, you can then query it using these other tools, right? You can query it using Athena, query it using Redshift. And essentially that's one of the use cases that we're particularly excited about, which is this idea of InfluxDB 3 on the front end as a real-time operational store that where it's automatically putting that data into object storage, into Iceberg tables, so that you can do large-scale data analysis in whatever tool you happen to like using, right? Because you can, it just like is spread widely. And I think one of the themes I caught from reInvent this last year is, obviously AWS is talking a lot about AI, but the secondary theme that I was personally excited about was this zero ETL theme, right? This idea that they're building a bunch of tooling so that you can get land data once and without having to create a bunch of extra code and other nonsense, use that data in a variety of other tools or through like the AWS product portfolio.
Yeah, I mean, from the way we think about the data strategy, you want to sort of create an end-to-end architecture where as a customer, you don't have to think about how your data is stored, and you can use common sets of APIs to access it. And Iceberg naturally really fits very nicely with that kind of model.
We just got another great question from the audience, so maybe we'll just we're kind of transitioning into Q&A time, which is great. So this one's great. Do we? So this person says they do complex processing of both time series and relational databases, or relational data. They say they're a SQL shop. So they say, how can Influx handle this use case? And they also put in parentheses after it, like an amen to the complexity of managing large databases. But, yes.
So, I mean, I think from, there's a couple of different versions of services and products that, that we're talking about here, from the, I think the InfluxDB2 that we have as the time stream for InfluxDB does not support SQL. It supports the sort of Flux query language. The live analytics offering does. Go ahead, Paul.
Well, I was going to say there is one thing in Flux where if you have relational databases and you have time series data in InfluxDB, there are libraries, there are packages in Flux so that you can connect to your SQL database and pull it in and pair that with your time series data on the fly. But you would have to write Flux for that kind of functionality. So essentially, it's like you connect to the SQL database, you write a SQL query to get whatever it is out of like Postgres or MySQL or whatever you're pulling from, and then a bunch of Flux stuff. So sorry, continue.
Yeah, no. And so, but I think I was going along the lines of, if you want to use SQL as your kind of time series query language, aspect. And, for that, I think that's something that's, as I understand it, is planned in or supported in Flux 3. From our side, it's the language that we use with our serverless service live analytics. And, we do see customers that, combine different time series services. So, they have something, they're using the time stream for InfluxDB for their kind of dashboarding monitoring use cases. And they use, the live analytics for the longer scale pieces. So, I think that there's a couple of different options there.
Yeah, for version 3 of InfluxDB, like the query engine, as I mentioned, is Apache Data Fusion, which is now a top level project. Andrew, you're the chair at this point?
I have the enviable position, yes.
Yes. So, and as Andrew knows, like it is a fully featured SQL engine. It has all sort of complex functionality, windowing, partitioning, all this other nonsense. And so it has a level of power that we actually never had in the InfluxQL query engine, right? InfluxQL was like the language that we created that looks kind of like SQL, so it feels a little friendly, but it's not actually SQL, and it doesn't have all the capabilities of SQL. So now with version 3 and with Data Fusion, we have a very fully featured SQL engine.
Although to be honest, InfluxQL, like if anyone's ever tried to actually implement the time series query in SQL, like it's oftentimes eye bleeding. Like there's pretty hairy syntax to give it to put it politely. So like InfluxQL actually has a much nicer syntax for expressing common time series patterns. So I kind of like it for that. But yes, it also it doesn't quite work the same way as SQL, which is a weird uncanny valley.
Yeah, I mean, I think part of the journey for us, part of the SQL journey for us, will be to add functions and basically syntactic sugar to SQL so that it isn't quite as gnarly to express, the normal, the simple time series use cases where people just want like, oh, give me the 95th percentile in 1 minute or 5 minute increments for this period of time or whatever.
So it looks like we got another question from the audience. It says they understand the use of time series world where there's high frequency examples. So the time series is often brought up in high frequency examples like trading and monitoring, where everything has to be done in seconds or milliseconds. And he says, if the time series becomes slower, would you recommend the same approaches, or the solutions become overkill? I don't really know what he means by slower, but perhaps the time windows over which you're looking for are longer or something.
Yeah, I mean, I'll make an assumption here that they're talking about slower in terms of ingestion rate. Or the sampling rate, and that's certainly one part of what makes processing time series data hard. But there's other aspects to it, in terms of being able to aggregate different measures, being able to support different cardinalities of workloads. So even in cases where you don't have a very high frequency or a high rate ingestion, you can benefit from using a purpose-built time series database. I think cases there we see it are in different kinds of fleet management. We have a very large industrial device manufacturer who's got lots of different sensors all over the world in factories and other pieces that report back at various intervals. These aren't kind of microsecond or even second or even sometimes hourly kind of reports, but it's really fundamental for this customer and others like it, that they'd be able to look at those time series in aggregate over long periods of time and use them to understand how things are performing, how they can make improvements, how they can predict failures and other pieces. So at least from my perspective, I still see that there's you can get a lot of benefit from using a purpose-built time series solution or database, even if you don't have very high rate ingestion or high frequency sampling.
Yeah, I think first, I would give the standard senior engineer answer, which is it depends. But I think to me, I really there are two sides of optimizing for the time series use case. So one is definitely this idea of scale and making the queries fast and whatever. And the thing is, if you just don't have that much data volume, that side of it isn't as important, right? If you're going to have 10,000 records a day being written in over time, it's just okay, well, you can, and you definitely already have an operational database as part of your toolkit, so you could just create a new table in that database and use that, and that's going to be for you from an operational perspective, from an application development perspective, that's probably going to be easier. But then the other side that how I view the time series use case is this idea of optimizing for developer productivity, right? Because what we've seen with time series is not just about storing the data and being able to query it, right? You need to collect the data from a variety of different sources. You need to transform that data before you store it. You need to monitor and alert on that data. You need to visualize it and all this other stuff. So when I think about that, I think of the set of tools that are available and how they come together that make it so that you have to write less code, less configuration to get to an overall solution for whatever it is you're trying to build, right? And that's what led us to build Telegraph, which is essentially a data collection agent that you can run on a server. It has 300 plugins to pull data from a variety of different well-known sources. In some of these are industrial stuff like OPC UA. Sometimes it's pulling data from message queues like MQTT or Kafka, or it's just pulling from well-known systems like servers and MySQL or Postgres or whatever. So you pair that with the other bits of tooling around the database, and maybe you get to a stage where it's okay, I don't necessarily have the data volume, but all these other things paired with the database make it easier to build a solution. Ultimately, that's really where you're getting to is how do you solve your customers' problems? Yeah. So
it depends.
Yeah, it depends.
All right, you guys ready? There's another question here that's somewhat, I think you could take it lots of different directions. So here we go. Using a time series database, how do you optimize that without having too much clutter, and how does the solution scale? So I'm not exactly sure what is meant by clutter, but I think you guys have broad opportunity to interpret that how you want.
I don't know. Well, clutter. I mean, the question is is more databases clutter? I was reading this Hacker News thread a couple of days ago, and somebody mentioned oh, what's going on? Why do you have 5 databases in production? That's insane. 5 different databases in your application. They're it's not 2007. What are you doing? And of course, other people piled onto this thread talking about well, you're using this system, you're using this system, you're using this system, you have these different things. So you're going to have many, many databases. And I think AWS certainly, I think is part of that, that they're firm believers in a bunch of different databases, right? There is no one size fits all. If there was one database that could store any kind of data and answer all queries in less than a millisecond, then great, we'd all pack it up and be done. But there are always trade-offs to be made for the different use cases. So I think, I think, if you're running inside of AWS and you can just pick a cloud provider hosted solution or a vendor hosted solution where you don't actually have to operate the thing, it makes it a lot easier to adopt another piece of technology to bring into your stack. But there's definitely like this idea of overall complexity of your solution. But again, I think for time series, I mean, again, like, pitching my book here, but I think for time series, it makes sense to, in many cases, to have a purpose-built solution for solving it. Now, how do you optimize a time series database? Do you have a couple of years for me to get into it, or? Yeah.
Yeah, I mean, I think it's, you really need to think about the use case, from the scaling perspective. Like, do I really care? You talked earlier, Paul, about the relatively the time value, if you will, of the data itself. And, is it important? How much of the data do I need to keep online so I can access it like I could from OLTP perspective, single double-digit millisecond latency? How much of it am I willing to put into a different storage tier potentially, to be able to keep it available for that sort of optimization use case or the analytic use case? And so, I think the solutions, that we offer will absolutely scale, as long as you think about the use cases and think through. And in some cases, you might want to combine different types of time series processing, for the different kinds of use cases.
Yeah, I think that's the problem. Is it always comes down to like cost benefit trade-offs, right? And when you think about like the thing you just said, which is, do you need to keep the data in a place where you can answer a query within tens of milliseconds or hundreds of milliseconds? That's a very different problem than I need to keep the data around for auditing purposes or for doing some large scale analysis where it's like, I'm going to kick off a job and it's going to take minutes or even hours to run, and I'm totally okay with that. And the difference is like, really, are you keeping your data in RAM? Are you keeping it on an NVMe drive? Are you keeping it on a spinning disk, fronted by some network service, right? And even within that, even within S3, you have, the different price tiers for less frequently accessed data. So that's the problem. I think it always comes down to cost, right? It's basically like, how much are you willing to pay to have, the data accessible within a certain amount of time?
And in the relational database space, we have transactional databases, we have analytic databases, and there's a kind of a well understood division there.
So it looks like we have time for one more question, and the last one that we have is, how do you handle data protection?
Well, this one must be a plant because I failed to mention data protection, one of the benefits of an AWS managed service. So mea culpa, but let's talk about that now, because security is job zero. And so, I think, one of the things that, from a managed service perspective for TimeStream, for InfluxDB, the things that we offer, the volumes on the instances are encrypted by default. We support encryption in transit by default. We give you tools if you want to use Secrets Manager to allow you to rotate credentials in terms of security best practices. We support automated service backups and restoration capabilities. So, it's always a shared responsibility for data protection. We, as a service provider, we don't always understand the data protection requirements that you have, but we give you tools and best practice types of defaults so that you can work with us and use those capabilities to build to build the data protection that you need. So it's certainly one of the big benefits that we see customers choosing managed services for, and there's a number of different compliance regimes, and so if there's specific questions for specific regimes, we're happy to follow up. But thank you for that one.
Thank you. All right. So I think with that, thank you both very much. It's been a wonderful, wonderful time. Again, thank you to Brad. Thank you to Paul. Do you gentlemen have any final words, or shall we get back?
No, thanks for hosting, Andrew. And thanks, Brad.
Thanks, Paul. Thanks, Andrew. Really enjoyed it. Thank you.
Thanks a lot.